Professor Bialis here. In this video we're going to be talking about section 7.5, which is solving rational equations. Now remember, a rational number, rational equation, rational expression, you're dealing with fractions. Nothing more than that. And here we're solving equations that have fractions in them. That's really nothing new. However, the fractions are going to be more algebraic in nature as opposed to just numerical. Okay, so let's just jump right into some examples, see how this plays out. There is one extra little thing that we need to pay attention to that I'll show you in the, after the first three examples or so. So again, this is section 7.5. We're solving rational equations, and I'm just going to say solve. Let's say we have that. Okay. Now, this is really nothing different than what we would have seen back in chapter 2 when we were just introducing the solving of equations. Okay, we have fractions here. Typically, we want to reduce them out, or I'm sorry, clear them out. We do that by identifying what the LCD should be. Now, this is different than when we were adding and subtracting. When we were adding and subtracting, we wanted to decide what the LCD is and then make them all become that denominator. We don't want that here. We want to use the LCD to get rid of the denominators. So we do that by multiplying every term by the LCD, which in this case is a 20. Okay? 20 divided by 4 is 5. 5 times x is 5x. 20 divided by 5 is 4. 4 times 4 is 16. 20 divided by 20, well, let's just go away, and we get a 1. So what we're left with then is a nice, clean, easy equation. So I'm going to subtract 16. And then divide by 5. And there we go. Okay? So again, that's really all it's going to come down to. What's going to be different about this chapter versus previous chapters is these denominators are going to turn into like an x plus 5, x minus 7, that type of a situation. But it's still determining what the LCD is, which we learned in the previous 2 sections, and then using it to clear those fractions out. Okay, so let's keep going. Let's say we have this one. Okay, now looking at that, we have a denominator, a lone denominator of x. A lot of people want to just mess with that fractional term because everything else is so nice. But to keep this balanced, we need to multiply every term by the LCD. 1, 2, 3, 4 terms all multiply by x. So we've got 2x plus 6, x squared plus 7x. Okay? Now notice what we're left with is no longer a rational equation. It turns into a quadratic equation. Okay? So with this, if we're solving this quadratic, I need to get a 0 on one side. I'm going to subtract a 2x, and at the same time I can subtract a 6. All of those cancel to a 0. That's what we wanted to happen. And then we get x squared plus 5x minus 6. We then go to factoring. X squared is x and x. Now be careful when there's a 6 and a 5, because you can get 5 in the middle with a 1 and a 6, or a 2 and a 3, depending on the signs that fall in. So please be careful with that. It's a negative 6, so we're going to require opposite signs. Now, to get the 5 with opposite signs, we're going to use a positive 6 and a negative 1. I then set each of those equal to 0. X is negative 6, and x is positive 1. And there we go. Okay? I'm going to come back to this in the next couple examples because I want to show you something with this, but this is worked out correct. Let's move on. How about something like this? Now with this one, again, first thing always, when you have that negative in between, it's not wrong to leave it there, but as we're distributing and clearing fractions and all that, it's very easy to lose or not distribute completely like we should. So the first thing I'm going to do is put this into that numerator. Then I'm going to switch gears and look at those fractions. In this case, my LCD between a 3, a 5, and a 15 is 15. And I have 1, 2, 3 terms. If I multiply by the 15, again, watch how this works. 15 divided by 3 is 5. I then distribute the 5. 15 divided by 5 is a 3. Distribute the 3. 15 divided by 15 is a 1. 1 times 1 is a 1. Okay, so there was a little bit more complexity with the distribution, but then look at how nice that equation turns out. After that, I just combine like terms. 5 minus 3 is 2x plus 13 equals 1. Subtract the 13. And then divide by 2. And there we have it. Okay? Let's look at something that presents a little bit of a unique situation. Let's say we have that. Okay? Now, this is where we get a little bit more of a complex denominator, but what's nice is those denominators are the same. So the LCD is that x minus 1, and how many terms do we have? We have 1, 2, 3. Don't forget about that. All of them are going to multiply by x minus 1. Okay? These cancel nicely. So nicely because we just bring that 5x down. Same thing is going to happen here. Just bring down the 5. Now this we have to distribute. So we're going to have 3x minus 3. Okay? Now we solve from there. Five minus 3 is just a 2. And then I bring this 3x over. And then I divide by 2. And I get x equals 1. Okay? Now, when we are solving rational equations, okay, there is something that we need to pay attention to that really hasn't been an issue up until this example here. Okay? Whenever you have a variable in a denominator, you need to check for something. Okay? That doesn't mean you need to check the whole thing. That's a good thing to do, but it's not necessary. What is necessary is to look for that bad situation in any denominator, which is when it's equal to 0. I first cleared denominators. I covered them up, essentially, so I didn't have to deal with them. But when I did that, I have to be careful that my answer doesn't cause an issue for the denominators that were there in the first place. If I take that 1 and I plug it into that denominator, 1 minus 1 is a 0. That's undefined. That can't happen. I didn't do anything wrong, but I took those denominators, I kind of pushed them aside. I have to make sure that what I get in the end doesn't affect those. In this case, it does. So what I get here, my only possible answer is actually no good. So what I have is no solution. And there we go. Okay. Now, I didn't really say anything about that here because all these denominators are locked in as constants, so there's no way of getting a 0. But once I get a variable in the denominator, I have to check for the zeros. Here, the only variable there was, or the only denominator there was x. If I plug a -6 in, that's not 0. If I plug a 1 in, that's not 0. So I was safe there. Here though, I have to check. So again, going forward, if you ever have a variable in a denominator, look for a 0. That doesn't guarantee it's right. I still could have made a mistake somewhere here, for instance, in this problem. But if I did everything right, my answer should be fine. The thing we have to check is the thing that when we do everything right, it's still just a bogus answer. Like this one, okay? We didn't do anything wrong, it was just a bogus answer. We have to check for those. It's nice to still plug these in and make sure it all balances out. But I wouldn't do that until I am completely done with any test or quiz that I'm taking. This check has to happen before I move on to the next problem. Okay? So let's look at a few more. Okay. So what I would do first is make those adjustments on the negatives. Put the negative there. Now I'm going to put the negative directly on the 2 there. Now, I would then think, okay, I need an LCD so I can multiply and then simplify and all that. Before I do that though, this needs to be factored. So I can see really what's in there. X squared is x and x. Then I'm going to have a plus 5 and a minus 3. I no longer need that. If you want to rewrite the problem because this is a little messy for you, then go ahead. Okay, it's not necessary though, but if it makes you feel better and you have a clearer picture, definitely go for it. Now, I can see that my LCD is the x plus 5 and the x minus 3 combined. So I'm going to multiply all 3 terms by the x plus 5, x minus 3. X plus 5, x minus 3. Okay. Now, I see a lot of students, they'll just write the x plus 5 here because they're like, oh, I know that that's going to go away, so I won't write it. I tend to see those students make a lot of mistakes along the way because they forget to distribute or they write something down wrong. They just start confusing the situation. Write the whole LCD down every single time. Now, what happens in this first one is nice because that all just goes away. 7x comes out very nicely. Okay. Here, just the x minus 3 goes away, and then I have to distribute this. Again, if this is too messy for you, write it down underneath so you can see that distribution that you're left with. And I have negative 4x minus 20. The next one is gone. I distribute that negative 2. So I got negative 2x plus 6. Okay? So, once I clear those fractions out, I solve that regular basic equation. 7 minus 4 is 3x. I then get the variable on one side. I then undo that minus 20 with an plus 20. And then I divide by 5. And there's my answer. Okay? So, remember, there's variables in the denominators. I need to check for those zeros. Now, again, guys, a 0 is a very easy thing to get when you have those opposites. If I don't have opposites going on, it's not a 0. So if I take 26 over 5, 26 over 5 plus 5, whatever that is, it's not 0. For that to be 0, I would have had to plug in a -5. That's not -5. Okay, so don't think, oh, I got to do all that calculation. It's just not 0, so I'm okay. Same thing here. 26 over 5 minus 3, that's not 0. I would need to have a 3 in there. Now, over here, okay, when you're checking, like truly checking, plugging in the whole thing and making sure they balance, you would always plug into this original quantity that we had given to us. But since we're just looking for that 0, it's okay if you plug into here, okay? If this is wrong, you got bigger problems with your answer, okay, that you should see when you are, when you're checking the whole thing at the very end. But if you're just seeing for looking for those zeros, I would just look at these quantities and you can very quickly and easily see it's not a 0. So this answer right here is perfectly fine. Again, I didn't check it completely. I just wanted to make sure, as long as I did everything right, that answer's fine. Okay? To see that I did everything right, I would still have to plug in the whole thing and make sure it balances. But I would only do that at the very, very end if you have time. Okay? Let's now go on to another one. Okay. Now, with this, again, first thing, put that negative directly on the 6 so you don't lose it. Then we have 4 terms, and the LCD is x plus 3. So all 4 terms need to multiply by x plus 3. Okay? This first one doesn't reduce anything. We just distribute the x to get an x squared plus 3x. This one cancels very nicely, and we just bring down the minus 6. If you want to put plus -6, that's fine, but again, try to make the notation as simple as you possibly can. This cancels, and then this distributes. So I've got 2x plus 6. Okay, before you move on, you read through all that, make sure it was written out correctly. Then you carry on from there. I would combine like terms. And then I get a 0 on one side because this is a quadratic. Again, at this point in the game, if you have a quadratic, it should be factorable. If not, then you made a mistake somewhere. When we get into chapter 11, that's going to change. Okay, but the whole point of chapter 11 is to talk about how we can solve those things without factoring. So I'm going to subtract 4x, and I can subtract 6 at the same time just to get it all done. All that's gone. I've got x squared minus x minus 12 equals 0. This then factors. X squared is x and x. Then I'm going to have a -4 and a +3. Set each of those equal to 0. I can add a 4. I can subtract a 3. If you find yourself making a lot of sign mistakes with that, then put +4 +4 -3 -3. Okay? Now, remember, if I have denominators with variables, I need to check for those zeros at the very least. If I plug a 4, 4 plus 3 is 7. I'm good. 7 here, I'm good. -3, -3 plus 3 is a 0. So, even if it just happens once, that's gone. So my only answer here is 4. You don't even have to really mention this unless they ask specifically, where's that extraneous solution? We call it extraneous because it's just extra. Okay, it's a byproduct of what we did. But if they just say, what's your answer? 4, end of story. Okay? Okay, let's do one more. Finish this up. Let's say we've got now, this is more of a formula-based type of problem. Whenever we have multiple variables, don't ever assume which variable they want you to solve for. They have to specify. In this case, I'm going to specify solve for A. Okay, I want you to get A by itself. Now, regardless, the first thing we need to do is clear those fractions out. So what I'm going to do is multiply all 3 of these expressions, or of these terms, by the LCD. And the LCD is A, B, X. Those are the 3 things I have. I list them, meaning I multiply them, and I see what happens. So I got A, BX, ABX, ABX. Now, A's are gone. BX times 1 is BX. B's are gone. AX. X's are gone. AB. Okay? Now, we want to get the A by itself. But notice there's 2 terms with an A in it. Whenever you have multiple terms with that one variable in them, you need to put them all together on one side. So, same as a normal equation, get the variable on one side. So I'm going to subtract AX. Okay, just for the ease of writing this, I'm going to put this stuff on the left. So I'm going to put AB minus AX equals BX. So I just used that symmetrical property and I flipped over that equal sign. Now, when I have these 2 terms with A, the reason why I wanted them together is because I need to have one A, not 2 of them. So when there's multiple terms with the same factor of A, what that allows me to do is pull that A out. And now I went from 2 down to 1. And then this distribution is a fancy way of multiplying. So I'm going to divide B minus X, and I have A equals BX over B minus X. And there we go. Okay. If we see this type of thing again in like a college algebra or pre-calc class, we get a little bit more specific with domain restrictions and whatnot, but right now we're just looking at the mechanics of these formulas and equations. So we're going to stop with that, and there's your answer. Okay? So that's pretty much it for this section. Again, it's just solving equations, it's clearing fractions, it's just now the fractions are a little bit more complex with those denominators. The other thing that's really, really important, whenever you have a rational equation, you check for those zeros at the very end. Okay? That doesn't guarantee your answer's right, but it at least guarantees that if you are right, if you did everything correctly, your answer's not just garbage. Okay? So in this case, this was a garbage answer. We didn't do anything wrong, it just happened. So we need to check for that stuff. So whenever there's a variable in the denominator, plug in and make sure that you never get a 0. Okay? So as always, work hard. Let me know if you have any questions, and I'll see you next time.